Section 4, electric motors, Unit 18, application of motors.
Okay, we don't wanna be this guy.
YouTube certified, nice.
Why don't I have that cartoon?
Don't wanna do that, okay? Don't go there.
Objectives. After studying this unit, you should be able to identify the proper power supply for a motor, describe the application of three-phase versus single-phase motors, describe other motor applications. Objectives continue. Explain how the noise level in a motor can be isolated from the conditioned space, describe the different types of motor mounts, identify the various types of motor drive mechanisms.
Motor applications. The proper motor must be selected for proper system performance. Motor must be able to function in the operating environment. Motors are selected based on the power supply, system requirements, motor insulation type, motor class, bearing type, and method of mounting the motor. The power supply provides correct voltage and sufficient current. Motor nameplate provides power requirements including voltage, current, frequency, phase, locked rotor amperage, and full load amperage. Motors should operate within 10% of rated voltage.
There it is, 10%. 10%.
Power supply continued. Motors have a service factor, reserve horsepower, frequency, number of cycles per second. Power can be supplied as single or three-phase.
Okay. We have a motor nameplate here. As you can see, Institute of Technology, it's IoT Motors. Right, here's your model number, your serial number, schematic number. Okay, you're gonna have the input volts, which is, it's gonna be on the label itself. The phase is also gonna be on the label. The cycles per second is gonna be on there. The full load current is gonna be on there. The horsepower is gonna be on there. That may or may not be on there. The service factor is gonna be on there. We'll talk about the service factor. The locked rotor amps may or may not be on there. The rotation and the frame size is all gonna be on that data plate that the motor that you're gonna be replacing. Okay, so all those have to be pretty much the same. So that's all the pertinent information. Okay. There is a plethora of information on the motors.
What other new words did you learn this weekend?
I learned that a couple years ago. Come on. You just haven't heard it yet. Okay, so here is a cartoon. Here's your first cartoon of the day.
Yeah.
It shows here the power supply is three-phase power supply, but it's powering single-phase motors. Whoa. Wow. See that? L1 and L2 are powering this one. L2 and L3 are powering this one. L2 and L3. Or L2 and L1 are powering this one. This is typical, and this is, you're gonna see a lot of three-phase units out there. They're wiring the single-phase motors on that unit this way. The only thing, a lot of times, the only thing that's three-phase on the unit is a compressor. And then sometimes a blower. Very rarely are the condenser fan motors three-phase. Okay?
Electric motor working conditions. Working conditions determine the type of motor to be used. Motors with centrifugal switches cannot be used in an explosive environment. Sealed motors are used in dirty locations. Drip-proof motors should be used in wet locations.
Okay, so you remember some of these questions from last week, huh? Drip proof? Drip proof? Wet?
Oh,
Rip.
yeah.
Wet? Sealed motors are used in dirty locations. Yeah. And centrifugal switches, because they spark. You're not gonna wanna use them in a gas station, right? Okay.
So use them at gas station, gotcha. Wait, so define dirty though.
Dusty, dirty.
Dusty, dirty,
Yeah.
so like an attic type of status?
No, that wouldn't be dirty.
Warehouse?
No, nah, not really. A really dirty location where I've been would be, Harris Feed,
Very sweet.
where they process the feed for the cattle,
I think, okay.
and it's just that feed dust just gets everywhere.
So a place where there's like a lot of dirt,
That's-
where it can become like mud.
Yeah, and dirty environments could be a unit next to a dirt road.
So like a dairy.
Yeah. Yeah. Okay.
Just want to specify.
Yeah. Good one. Good one. Good question. Continue. Somebody.
Installation type or class. Listen. Motors can safely operate up to a predetermined temperature. The installation type determines the maximum allowed safe operating temperature. The installation type rating is determined by the allowed raise in temperature above the surrounding ambient temperature.
Okay, so the installation class, this is another book right here, check it out. These are the different classes of installation class. Okay, so if we look at some of these motors, we'll see there's, class A, class B. We don't have any class F or class H in this lab anyway. But the installation class is the, maximum motor temperature. And it refers to the insulation on the winding itself. You remember the winding? You look in the winding down in the motor, they look copper colored or red colored. That red stuff is the shellac that goes on the winding. It keeps the windings from shorting out. Okay, so when you start going past the heat rating of that shellac, it breaks down the shellac and it starts to shorten the motor out.
So that's what you smell? When they start overheating?
What smell?
Burning odor?
Burning motor smell?
Yeah.
What does the burning motor smell?
I don't know, is
smell
that
like?
shellac or?
What does it smell like? Can you describe it?
Like burnt wires.
It has its own smell.
Somebody hear it?
Maybe.
What's up, Steve? I was gonna be here on time, but, you know, I had to turn back home halfway through my commute.
Okay.
Sorry about that.
Sorry. There's a door closed with people up there talking.
Oh yeah, they're loud. Talking about something great.
Okay, so we understand the insulation class of the motor. All of them will have a chance later on today. So look at some of these motors and look at the insulation class and all the pertinent data. Isn't that exciting?
Yeah.
Here's another one. This particular motor is totally enclosed. It's cooled by the air going across it. It says fan cooled. Model number, catalog number, 1 horsepower. Ooh, 1 horse. There's the RPM right there, 1725. Here's the service factor, is 1. The dual voltage, 115 and 230, 60 cycles, single phase, code J. Here's your amp draw, 12 and 6. You pick. You pick which amps you want, because you're gonna pick what voltage you want, right? 40 degrees Celsius ambient, insulation class right there.
Class A.
Ooh. Okay. I don't know where I got this one. This one is a, I don't know where I got that. Hey, I got it. So. And then of course the voltage connections, how you hook them up in different voltages over there, right? Isn't that exciting? That exciting. Okay, let's talk about bearings.
Types of bearings, determined by load and acceptable noise levels. Sleeve bearings used on light loads and low noise levels. Lubricated with oil. Ball bearings, noisier than sleeve bearings, lubricated with grease.
Okay, so two basic types of bearings in the motors, ball bearings or sleeve bearings. One's lubricated with oil, the other one's lubricated with grease.
Motor mounting characteristics. Determine how a motor is secured during operation. Rigid motor mount bolted to fan frame / pump. Resilient rubber mounts reduce motor noise. Cradle mounts, motor sits in the cradle. Rigid base mounted to motor. End mount used on small motors. Belly band strap mount, strap around.
Okay, here we go. Bruh.
Bruh.
Okay, so here, this particular motor here is a cradle mount. It's actually mounted on the resilient rings. The resilient rings are these things right here. They go on the motor. Okay, so the cradle mount. This is a permanent mount here. This mount is actually attached to the motor frame. Here's a belly band mount. See where it goes around the belly of the motor? And then this one would be more like an end mount. Okay, you see all the differences there? It's really isn't really an end mount, it's like a side mount. You can do the motors, when you do use the motors, if you look at the motors, they have the bolts going through them. Okay, what I've done is I've taken the bolts out and put the ends on this side, so you can mount it from the bottom. Okay. You good with that?
Motor drives connect the motor to the driven load, transfers motor's power to the device, direct drive motor shaft, connecting the ring to the driven load. Driven load turns at the same speed as the motor. Belt driven uses bolts and pulleys. Driven load can rotate at different speeds.
Okay, so here is a direct drive, a motor with a coupler. And we've seen this, you've seen this movie before, right? These are belt drive. You can see the motor's sitting next to the compressor and there's a belt connecting the motor to the compressor. These can be adjusted as far as the speed is concerned. So this motor is gonna turn, say, 900 RPM. And you have a 4-inch pulley on it. If you have an 8-inch pulley over here, that means this is gonna spin half that. Okay. The formula in the book to figure out what the ratio is on motor pulleys. But we don't really need to know that right now. When you become journeyman, yeah.
proper motor must always be selected for proper system performance. The power supply provides proper voltage and current capacity for proper motor operation. Motors should operate within 10% of rated voltage. Summary continued. Working conditions determine the motor to be used. Sleeve bearings operate quieter than ball bearings. Application determines type of motor mount used. Motors can be used for direct or belt driven applications.